Hello everyone, myself Dr. Sriparna Shakha, and in this lecture series we are talking about genetic algorithms. So till now we have covered how to reproduce new states in genetic algorithms using selection, crossover and mutation. Then we have covered the basic block diagram of any genetic algorithm, and then the GA operators and how to use them to maximize the output of any genetic algorithm. Then we have covered two distinct strategies of GA, namely simple genetic algorithm SGA and steady state genetic algorithm SSGA. So now in today's lecture we are going to cover different encoding techniques. So here there are mainly four different encoding techniques. First one is the binary encoding, second is the real value encoding, then the third is the order encoding, and lastly we are going to cover tree encoding. So first the binary encoding. So what happens in binary encoding? That our gene is represented by a string of binary bits. So a string can be represented by any combination of 0 and 1. In the example you can see that is the 4 chromosome structure has been given, where each position of any individual gene has been represented by either 0 or 1. So that is the binary encoding. A very interesting problem that could be solved using binary encoding, that is knapsack problem. So what happens in this knapsack problem? Suppose you have a bag. So this is a bag basically. You have a fixed capacity of this bag, so that you cannot change. And in this bag you need to place suppose 4 objects. So there are 4 different objects and each object has its corresponding capacity. Okay, now your aim is to take as much items as possible, but the total capacity of this bag that cannot be exceeded. So the problem is to take as much items as possible but not exceeding the capacity of the knapsack. So that was the problem. So let us see how we can solve it. Suppose you have n different items that may or might not be placed in the bag depending the total size of the bag. So each item has a cost, suppose Ci. So that is the item cost is Ci, and for that particular item the weight is Wi, where this I value varies from 1 to n and total capacity of this bag is W. So what do we need to optimize? Or here we need to optimize to the maximum value, that is for all I, Xi multiplication with Ci and with multiplication of Wi, where Xi can be either 0 or 1 based on whether ith element is selected or not. And here we need to keep, that is we cannot exceed the total weight of the bag. So if suppose the total capacity of the bag is suppose W, that is a capital W, so Xi multiplication with Wi, this total value cannot exceed W, so this total value will be less than equal to W. So this is the optimization problem that you can easily solve using binary encoding technique. Why binary? As here 0 and 1 are used to represent. So this is the binary encoding problem. So what are the advantages? That it is computationally inexpensive, as operations with binary representation is faster, and any optimization problem can be represented in the binary format. And in the disadvantages we have, that is extra effort needed to convert into binary format. Suppose something is in real valued, so you are going to have an extra effort to convert the real value to the binary value. Then the accuracy is dependent on the binary representation, how we are going to successfully represent any entity. So based on that the accuracy is dependent. Okay, next type of encoding technique is the real value encoding. Here a gene is represented by values or symbols. Here you can see that is positive and negative, both the numbers can be over here, and whatever their exact value, by that you are going to represent it. So now we have an interesting problem over here, that binary representation of real values. That is how any real value can be represented in a binary format. So suppose a real value that need to be mapped where the upper and lower end of that is XL and XU, where L and U stands for lower and upper boundaries of X, and the string length of the chromosome suppose is small n. So that is log base 2 XU minus XL divided by epsilon. So this can be represented, that is a precision that is can be represented by this formula. From this equation you can come to this equation. So, okay, now the binary equivalent for X is supposed X suffix B, so that can be represented by this formula. This is how any real value can be represented in the binary format. So we have came to the third encoding technique, that is the order value encoding. So what it is? That is, here a gene is represented by a sequence of elements. One beautiful problem and very common well-known problem, that is the TSP or traveling salesman problem, that can be solved here using the order value encoding. Suppose you have 5 cities and you have to tour the 5 cities, and how the ordering of the cities will be such that you need to travel the minimum path. So here suppose this is the path, so that is the order you can represent it, that is A, then B, then C, then D, then E. That is, this ordering is used to represent the chromosome. So this is the problem of a order value encoding. So what is the objective of TSP problem? That is the visit all cities one after another, and the objective function is that to find a tour with a minimum cost involved, and the constraints are, that is, all cities must be visited and each city can be visited only once except the starting city. As is a tour, so we are going to start from, if we are starting from suppose city A, so we are going to need to come to the city A to complete the tour. So that is, the starting city will be visited twice, so that is except the starting city. And what are the design parameters? You need to find out the path cost, so that is, you need to find out the Euclidean distance between any two cities, that you need to minimize. That is the minimization optimization problem. And now the fourth one, that is the tree encoding. So here a gene is represented in the form of a tree or objects. So if you have already gone through the graph theory on the data structure, you know that is any tree can be represented by 3 orders, that is in order, pre-order, post-order. What happens in in order? That is a parent node. Suppose here the parent node is E and it has a left child B and a right child C. So in order representation is B, then A, then C. Sorry, I told that is the in order representation is B, A, C, and the pre-order representation is A, B, then C, and the post-order representation is B, C, then A. So this is the tree encoding. So with this we have come to the last. Thank you everyone for investing your time, and happy studying.